This is no static, and we will be solving a present value problem of the type found on the Financial Mathematics Actuarial exam. First, the problem. At an annual effective interest rate of I greater than 0, the following are all equal. 1. The present value of 10,000 chicken fingers at the end of 6 years. 2. The sum of the present values of 6,000 chicken fingers at the end of year T and 56,000 chicken fingers at the end of year 2T. And 3, 5,000 chicken fingers immediately. Calculate the present value of a payment of 8,000 chicken fingers at the end of year T plus 3 using this effective interest rate. Okay, let's get started. We're told that we have an interest rate of I, and I is positive, but actually we won't be using I for this problem. We'll be instead using the present value discount factor known as nu. It's defined as 1 over 1 plus I. Now, we're given 3 statements, and we're told that the 3 things in those statements are all equal. So we need to write an expression for each of those 3 things. The first thing, the 10,000 chicken fingers at the end of year 6, can be represented by 10,000 times nu to the 6th power. The second item, 6,000 chicken fingers at the end of year T and 56,000 at the end of year 2T can be represented by 6,000 nu to the T power plus 56,000 nu to the 2T power. And the third thing, 5,000 chicken fingers payable immediately, is just simply, in present value, 5,000. Okay, so now we have expressions giving the present value of each of those 3 things, and we're told that these expressions are equal. So now we can start picking and choosing about which ones to set equal in order to figure out what we have. First, we're going to use 1 and 3. And we'll set 1 and 3 equal to each other, giving 5,000 is equal to 10,000 nu to the 6th. Then we solve 1/2 equals nu to the 6th. And this then gives that nu is about 0.8909. Okay, we could figure out what I is. It's 12.25%, but we don't actually need I at all. So we used 1 and 3 to figure out what nu is. Now we're going to use 2 and 3. Now, you might say, okay, but this looks complicated now because of that t in the exponent. But with all of these problems, if you ever see a time and twice the time, it's a hint that you're going to use the quadratic equation. Let's show how that works. Using 2 and 3, I have that 5,000 is equal to 6,000 nu to the t plus 56,000 nu to the 2t. Okay, now it may not be apparent here, but there's a quadratic equation hidden here. If we let x be equal to nu to the t, the quadratic will come right out at us. We'll rewrite this. We have 5,000 equals 6,000 x plus 56,000 x squared. Oh, there we have a quadratic. Now we solve this using whatever method you want to use for the quadratic equation. I'm not going to detail that here because you no doubt know how to solve a quadratic. When we do that, we get x is equal to 1/4 for the positive root. So this implies that nu to the t is equal to 1/4. Now if we wish, now we could solve for t because we know nu, and we know nu to the t, so we can use logarithms to find out what t is. However, we don't need to. We're asked, if you recall, we're asked to find the present value of a payment of 8,000 chicken fingers at the end of year T plus 3. Okay, so to do that, 8,000 at year t plus 3, we simply write down the expression and see what we can do with it. The present value of 8,000 chicken fingers at year t plus 3 is 8,000 times nu to the t plus 3. Put that in parentheses just to be certain here. Now, we use the law of exponents to change this into 8,000 nu to the t times nu cubed. We know nu to the t, it's 1/4, and we know nu, it's 0.8909, so we can simply cube that nu, substitute the 1/4 in, and we have what we need. So this is 8,000. Nu to the t, as I said, is 1/4. And then nu cubed is approximately 0.7071. When we multiply that all out, we get 1,414.21 chicken fingers. All right. Thanks for watching.